Bananas in pajamas are coming down the stairs. Bananas.
Hey, welcome to the Nan McNan Show. I'm your host, Nan McNan, and today we have the very special Miss Incredible with us. Welcome, Miss Incredible.
Thank you, thank you.
How have you been?
Well, to be quite honest, my legs have never felt quite the same after that incident on Syndrome's Island.
Golly, how far can you stretch exactly?
30 meters.
Golly, I'm surprised your suit just hasn't, ripped down the middle yet.
Well, to be quite honest, my designer, Edna Mode, is quite a genius. She said,
your sword can stretch as far as you can without injuring yourself and still retain its shape. Virtually indestructible. Yet it breathes like Egyptian cotton.
Wow, Egyptian cotton. That's incredible.
Yes, but not only can it stretch lengthwise, but it can stretch in all directions too. Like that incident where I had to stretch my body into a shape of a boat.
Wow, so your suit can stretch 30 meters in all directions. That sounds ridiculous. I don't believe it. I don't believe it. Nan, are you thinking what I'm thinking? I think I am, Amy.
Can Miss Incredible's suit reform after being stretched for 30 meters?
It's time to test this myth.
Father Einstein, Father Newton, please bestow on us the strength that we need to attack and conquer this myth. We hope that you will visit us and enlighten us during our times of hardship as we voyage through the world of physics. Amen. Here we have a pair of spandex leggings. We need to find out how much pulling force this pair of leggings can withstand. And that's simulating Miss Incredible's ability to stretch out her legs. And it cannot even withstand the force of being stretched in one direction. There's no way it can withstand the force of being stretched in all directions. We're on our way to our secret laboratory now, where you will get an inside look of how we test this myth.
Hello.
We have to tie the leggings to the rail really, really tightly to control for length. Our initial length is 64.12 centimeters. We will first attach a 10-pound chain and remeasure the length of the leggings to account for the amount stretched by the chain weight.
Next, we will add a 5-pound weight and take down the measurements of its new length. After, we will vary by increments of 5 and 10. We will continue to add weights and take down measurements until the material rips.
Now we're at 35 pounds. The leggings are now 112.42 centimeters long. They've been stretched a total of 48.3 centimeters. We're going to fast forward to 55 pounds. We're not showing you all the clips, or else that video will definitely exceed the 10-minute limit.
Maria wouldn't be very happy about that.
55 pounds. This is when we started hearing ripping noises. £65.
Look at Nan running away. It was a little too intense to handle.
Don't judge me! £75. The leggings have now stretched to 144 centimeters. It was getting really, really heavy, so we had to ask for help. At this point, I didn't even bother trying to pick it up. It's like 3/4 of my weight.
£85. At this point, we pretty much can tell that the leggings are going to rip because we are hearing a lot of ripping noises.
The spandex tights should have ripped now, but there are objects in the foam pit that are obstructing the path of the weights.
We found breaking point.
We move the objects to let the weights fall and cleanly rip the spandex.
Should be good, right?
And they rip.
Awesome!
Now that we have all this data, we need to analyze it. We subtract the length measurements to find out how much the leggings displays cumulatively compared to its initial length.
Now we can use Hooke's law of elasticity, which is F equals kx, to analyze our data. X is the displacement from equilibrium in meters, and F is the amount of force applied, or the restoring force exerted by the material in newtons. And K is the spring constant, which is something we don't actually need, but we can calculate it if we really wanted to.
Since F equals mg, we can sub in mg into Hooke's law and make the equation mg equals kx. We are using 9.81 as our g value because it is the acceleration due to gravity. Hooke's law states that the amount of deformation of an elastic object is proportional to the force applied to deform it.
This really means that when you apply force to it, you expect the x value, the deformation of how much the material is being stretched or compressed, to be proportional to the force you apply. And since it's proportional, you also expect the material to be able to reform to its original length. This is what a typical graph of a Hookean material would look like. Our chart looks like this. As you can see, past this linear part, you exceed the elastic limit of the graph. Materials past this point deform permanently. On our graph, it's clear that after 111 newtons of force, our tights deform permanently. Our leggings only reached 154.51 centimeters before they reached their breaking point.
This is only 0.127% of our target length, which was 30 meters. We can assume that since her suit is made out of the same material, it will behave in the same manner and deform at only a fraction of our target length.
Myth busted! Edna Mode, you're not a genius designer, you're a con artist.